Example 4.15, 2 blocks and a cord. A block of mass 5 kilograms rides on top of a second block of mass 10 kilograms. A person attaches a string to the bottom block and pulls the system horizontally across a frictionless surface. Friction between the two blocks keeps the 5 kilogram block from slipping off. If the coefficient of static friction is 0.350, what maximum force can be exerted by the string on the 10 kilogram block without causing the 5 kilogram block to slip? So once we've got our masses and mu sub s written down, let's think of the free body diagram for the top mass. We will have the normal force acting upward and the gravitational force acting downward, which will be mg. We will have the frictional force not acting backwards. If the motion, we've got the tension going this way, so we will have the frictional force going this way, and we want the friction to be its maximum force because we want it to just be at the edge of falling, so it will be mu sub s times the normal force. In this case, the normal force is mg. And we will have the acceleration for this be mu sub s mg over m, which is the sum of the forces divided by the mass. Now, for the bottom block, we will have the tension acting this way, the normal force, or the mass, we will have mg acting downward on it. We will also have mg acting down on it because we've got both those weights on top. We will have no frictional force from the bottom, so it'll be 0 down here, but on the top we will have a frictional force of mu sub s mg, lowercase mg, to counterbalance this. So our acceleration on the top, I already wrote the acceleration for that guy. On the bottom we'll have acceleration equals the tension minus mu sub s mg, and that will be divided by, we're only considering this block here, so it'll be m. Now if we did think of the whole system, it will be a mass of m plus m, and the only sideways force on it would be the tension. So it'll be, I think, acceleration equals tension divided by m plus m, m plus m. So this equation doesn't have any unknowns in it at all. Acceleration equals mu sub s mg over m cancels out, so we'll just have mu sub s times g, which is 0.35 times 9.8, or 3.43 meters per second squared. Now we can solve this for, well, we should be able to solve either one of these. This one is tension equals mass, big mass times acceleration, plus mu sub s mg. And plugging all the numbers into there, I got 51.5 newtons. Finally, for a check, I can see whether this tension, 51.5 newtons divided by our mass of 10 plus 5 pounds, or 10 plus 5 kilograms, comes out to be 3.43, and it does, meters per second squared. Question: what would happen if the tension force exceeded 51.5 newtons? if we had more than 51.5 newtons here, then the acceleration would increase a little bit, and we would be past the maximum static friction between the blocks, and the top block would begin to slide. Finishing off, there is an Applying Physics 4.1 talking about a car. The force of friction, it's a static friction because if the wheel or the tires are not sliding on the road, but the static friction from the road on the tires is going forward. The static friction from the tires on the road is going backwards. Also, the air resistance, R, is acting backward on the car. With air drag, the air resistance acts upward, and his velocity is going downward, and the air resistance generally, according to that Wikipedia page I found earlier, the air resistance is proportional to the square of the velocity, though it is also proportional to the surface area, or the cross-sectional area, which is why a skydiver who tries to flatten themselves against the wind will fall slower than one who is gotten themselves into a diving formation.